Hi everyone, we're going to do a quick demo of decomposing calcium carbonate, or basically taking the shell of an egg, which is calcium carbonate, and having a reaction between that and the acid in vinegar. So I've collected the items that you need. You need at least 2 eggs. You can keep them in the refrigerator when you're not using them. You're going to need some water. You're going to need salt, so sodium chloride. You're going to need some sugar. I happen to have a package of powdered sugar here, but white sugar is fine as well. You're going to need about a tablespoon of the salt and the sugar. You're also going to need some vinegar. You're going to need at least a cup, or about 8 ounces probably, of the vinegar, maybe more, and you will need more later in the semester. I tend to go for the cheap ingredients. This cheap distilled white vinegar is fine, but if you have around other types of vinegar, rice vinegar, red wine vinegar, that's totally fine to use too. Also, you're going to need between 1 and 4 clear cups, glass, plastic, whatever. Some kind of measuring spoon. That could be a tablespoon, that could be just a spoon that you use, and then some kind of measuring cup. I've got one that I would cook with, but you could even just use like a jar from the dollar store that's got a couple of lines on it to help you measure. All right, so you've collected all of your things, and you're going to see that you can do the same experiment over and over with eggs. Eggs have gotten really expensive lately, so we're kind of doing the simplest, cheapest version of this. But if you have lots of eggs around, you could grab more eggs. You will need at least 2 eggs though, okay? So I'm just going to show you how to work with 1 egg at a time, all right? So you're going to have your 4 cups, or you can just reuse 1 cup over and over. So I'm just going to have my 1 cup. This will be cup 1, okay? We're going to put an egg. Make sure the container is big enough to hold your egg. First of all, you're going to take that egg and you're going to see how much water it takes. So I'm going to go grab some water to cover that egg completely. And we want to do this so that we can have a consistent amount. So let's see here. All right, so I had about half a cup of water and it didn't take all of that, so it's about 1/3 of a cup of water is what I'm going to end up using for all of my experiments now. And that's going to go here in my data table. So the volume of solution, I'm going to use 1/3 cup in all of my experiments. Every experiment will last at least 5 minutes. Temperature, I'm going to do mine on the counter. Okay, so I'm going to say room temperature. You could check what your temperature is for that day. So for me today, it's 74 degrees Fahrenheit. And then the size of your egg, wherever you got your eggs from, check your container. These are large eggs, right? There's different sizes of eggs. So I'm going to use a large egg for all of mine, okay? So I've now got cup 1 with my egg covered with water. This is going to be my negative control. In other words, something water that is not going to react with my calcium carbonate eggshell, all right? If you have pH paper, if you've received some, you can measure the pH. Now, this pH paper has to last you all semester, so we want to use like the tiniest amount possible, and we don't want to contaminate it with anything in our kitchens, your bench, wherever you are. So the way to do this is dip, say, like a knife or something into that, and see what color it turns. All right, now I have the little sheet here with all of the different colors on it. You have this in your lab PDF. All right, so I'm going to see, this is kind of a greenish color. I would say it's closest to 7, maybe between 6 and 7. So I'd say the pH of that water is 6 to 7. A range is fine. All right. In another option, I've linked this pH values of common foods and ingredients, and you can see they all kind of have ranges, but you can use this to estimate what your pH would be if you do not have pH paper, okay? But again, super teeny tiny bit of pH paper. You should have most of it left because we're going to use this in a later experiment. So you're just going to use 5, maybe 6 super teeny tiny pieces of it today. So this experiment's going to continue for 5 minutes. You may see, I don't know, a couple bubbles on your egg, but really you shouldn't see much of anything interesting happening here. That's the whole point of a negative control, right? So you're now going to dump your water out, rinse your egg off, and then we will move on to cup 2. All right, cup 2, we're gonna turn this into an aqueous solution of NaCl, an aqueous sodium chloride solution. So we're going to put a tablespoon of salt. So grab your salt. You can measure super carefully with a measuring spoon or just use kind of a consistent amount in a regular spoon. So a tablespoon of salt, and we're going to add again our 1/3 cup of water. Once you've got that tablespoon of salt and that 1/3 cup of water, you're going to stir it around. If you have pH paper, get another little piece of pH paper, test the pH of this. Otherwise, reference what salt water might be on that list. And now we're going to take our egg friend again and put it in here. You might notice that it floats a bit because the salt water is denser than the plain tap water was. But we're gonna let this sit for 5 minutes and see if we start to see lots of bubbles on that egg, all right? Assuming you don't see anything, take the egg out, rinse it, and then we're going to repeat again with cup 3 sucrose, so that's going to be some table sugar. If you do use powdered sugar, it's less dense, so maybe use a little bit more than a tablespoon, maybe 2 tablespoons. As you go, you should be writing down your observations for each of these in table 1, all right? So here, say cup 1, we just had the pure water. In cup 2, we added the NaCl, so added 1 tablespoon of NaCl. And then you're writing down observations, including words, times, pHs, something after 5 minutes, 12 hours, 24 hours. You probably aren't seeing much of anything interesting so far. So cup 4 is where we're going to use our vinegar, which is an acid, in place of these other solutions that we've been doing, okay? And this vinegar, note, is 5% acidity, so that means the other 95% is just water, and that's why we call this an aqueous solution, all right? So I'm gonna use my measuring cup and measure out 1/3 cup of vinegar. Once I've got that measured out, pour it into my cup, and I will add my egg. All right, if 1/3 cup is not quite enough, then measure out a little bit more. Pay attention to how much more you put in, just so you can make a note of that in your observations. So I'm gonna add an extra tablespoon of vinegar, okay? Now, as this sits, the acid in the vinegar should start to react with the base, the calcium carbonate. So hopefully what you will see happening, and I don't know if you can see it in the video here, is hopefully you'll see little bubbles forming all over the surface and starting to bubble off. That's what a chemical reaction looks like here, okay? Those gas bubbles, you should be able to figure out what they are from the learn section at the beginning of the experiment. So that now, because it's reacting, is a winner. You're going to either leave it on your counter or put it in your fridge for 24 hours or more if you want, and see what happens, okay? See if that outer calcium carbonate eggshell completely reacts or partially reacts after that time has passed. And I didn't show it, but again, if you have pH paper, you can, with a clean knife, test what the pH of that vinegar is, and you can see it's different than the water, right? So you'll be able to measure that. All right, so this is gonna sit for 24 hours, see what happens. For round 2, you're going to need to check in with a classmate, however your instructor has told you, and design 2 additional experiments. Now, in designing those, you're going to write down what you did here. Ideally, you keep everything the same except for one thing. So let's just say I'm curious to try dissolving my egg in lemon juice, okay? So same size egg, large, same temperature, room temperature, same time, and the same volume of solution, okay? Except for this time, I'm going to use 100% lemon juice and see what happens, okay? Again, if you have a little bit of pH paper, you can measure that or reference that list to see what the pH might be. If your first idea is boring and doesn't start to bubble like this, then you will use your second idea, okay? And as you're planning this and also writing about it, you're going to be comparing your round 1 results to other classmates, so you will need to connect with each other at some point. As you do round 2, maybe you want to do lemon juice and your classmate says, hey, I'll do lemon juice too. That's interesting because then you can validate each other's work, okay? So you're going to do the same setup and see if you can treat another egg That's your second egg, and get it to react, okay? Your second round here, if the first idea doesn't seem to be working, just let the second one sit for a whole 24 hours. Some reactions happen a little bit slower than others, so that will help you out, all right? One other safety note on this. If you want to, you can use something from around the house, okay? However, read the directions very, very carefully, including all the warnings, safety, everything. You want to be super safe as you put your egg into other chemicals, all right? So hope that gets you started and have some fun.